Okay, hope my screen is visible. Yeah, you can see there is a plot called as error bar plot here under statistical distributions plot. So in this plot, what happens is data points will be plotted, and what is the maximum error, or what is the maximum value the actual point might possess, and what is the minimum value the point might possess. For example, to give you guys an example, let me just create a text box. So let's say there was a point where x was equal to 5, and this is a measured value. And what is the possible error that might be, or that might have occurred during the process of measuring the value of x? So if I can give you a range, x can be as big as 5.5 and x can be as low as 4.5. Are you guys able to understand? So the maximum value the x can possess is 5.5. The minimum value x can possess is 4.5. If we assume this and if we plot x is equal to 5, you will get a possible range for the x where the value of x might lie. And this assumption just implies that there is possibility of error. That's why we have the range. So we will just plot one graph, and then if I explain it, maybe you will understand it better. I'll just remove this and let me just write error bar plot. So the first step of importing the libraries, okay, we are ready now. We will create some data so that we can better understand the error plot. So I'll create something called as x, and we will create a list. So I'll just use numpy arrange function, and from 1 to 6. And if I print x, okay, there are 5 values from 1 to 5, and it's a numpy array. Everyone is understanding, right? I think we have used np.arrange function in the previous sessions. Okay, now let me create y, and let me again now create a numpy array, and within that I'll just specify a list. So as there are 5x values, let me also create 5y values. So 2.5, 2.3, 2.5, and it can be 2.9 or 3.2 and 3.6. Are there 5 values? Yes, I think there are 5 values. Now again, I'll just create something called as y error. For now, just write the code with me, and I'll explain it in some time. 0.2, 0.3, 0.1, comma, maybe 0.25, 0.2. Run the code. Okay, there is no error. Good. So there is a concept called as upper bound and lower bound for the error. for error, or we'll take one example. We'll assume that x was equal to or y was equal to 6. And the error that might have occurred during the measurement, for that, the upper boundary, let's set it 6.8, and lower boundary for the y value, let me just specify it as 5.2. Are you guys understanding what is upper boundary and lower boundary? I'm just telling you the range of y. Like y can be as big as 6.8, y can be as low as 5.2. So that is the range of y. But when a person measured the y value, he got 6. So that is the range of error. And in this case, in the particular case which I'm giving you as an example, upper boundary for y is 6.8, lower boundary is 5.2. If you have understood this, hope all of you have understood. Yeah, four of you apart from me. Now, there is something called as symmetric and asymmetric error. So, symmetric error is when you write, do you remember in maths sometimes we write 6 plus or minus 2? Do you remember writing something like this? Like 6 can be either 8 or 6 can be either 4. So, you write plus or minus 2. So, in this case, the 2 part, this is the error part, and in this case, it is an example for symmetric error, because even if you are adding it, you are adding 2. Even if you are subtracting it, you are subtracting 2 from the value. So this is an example for symmetric error. For an example for asymmetric error is, for example, if y is 6, if y is 6, upper boundary for y, let's assume 9, lower boundary for y, let's say 2. This is an example for asymmetric error. Are you guys able to understand? The difference between upper bound and y is 2, but the difference between lower boundary and y is 4. So there is difference. This is an example for asymmetric error. Okay. So this error bar plot is used when you want to plot what can be the error, what can be the possible error for an experiment, let's say, that you have conducted and you tried measuring values. I'll just erase this text part. Hope you guys have understood and hope you have made notes. Now coming back to the code. So we have x, and for all the 5 values from 1 to 5, y value was measured, and for every y value, we have an error value under y error variable. And in this case, this is an example for symmetric error values, because we are not assigning two separate lower and upper boundaries. We are just writing these are the error values for respective y value. Are you guys able to understand? I'm just going slow because I think this is something new. Okay, now let us plot the error bar. So plt dot error bar x comma y, and after y you write comma and you also specify y error. There is a variable called as y error. You specify that as well. And this fmt is equal to quote o. What this will do is, if I print this, you can see there is a circle which represents the point. For example, the first y point was 2.3, and this, if you can see the cursor, that is representing 2.3. Are you guys able to understand? And this y error, you have got a straight line passing through that circular dot. That is the range of error, or in statistical terms, the standard deviation or variation in the y value, possible variation in the y value. So the upper end of the straight line will give you the upper boundary for the possible error that might occur in measuring the value. The lower end will give you the lowest possible value for the y. Are you guys able to understand? As we have under x, there are 1, 2, 3, 4, 5 unique values and whole numbers. For 1.5 and all, we have got nothing above in the vertical direction. We have got error bars for 1, 2, 3, 4, and 5. Hope you guys understood. Okay, and now let's just try manipulating the same. So let me create a title, and let's call it error bar plot, and x label, y label. Let me just name the x as sample and y as measurement. I think now you will better understand. Now if I plot the same, it says on the y-axis it's measurement, and whatever the circular dot that you can see, that is the measured value, and the straight line will give you the range while measuring what was or what can be the possible error that might have occurred, and it just gives you the range. Now again, if you want to add a grid, I think you guys are well aware of these things. PLT is equal to grid will give you the grid. And now let's try learning some parameters. So within this error bar function, there is something called as cap size. And if we set it to 5, you have got a cap for the straight line. Are you guys able to see it? A horizontal line is present on top of the error bar. Yeah, and you increase the number, you are going to increase the size of the cap size. And then there is something called as color. If I set it to green, you can see I have got the whole plot in green color. And there is something called as e-color. And if I set that to red, you can see the measured points are in green, but the error range that is represented by this e-color parameter, it is present in the red color. Are you guys understanding? Okay, now let's create one more called as label, and let's write measurement plus or minus, I don't know how to write that, plus or minus error. Now if I run this, there is no change in the plot. And if I create plt.legend function here and then run it, you can see a short box present here. Everyone understood, right? So if you just write the label, it will not work. You also have to use this label function, plt.legend. This legend and label, they work together. Now let's explore different ways in which we can tweak this plot. if you want to, keep it scientific, for example, you measure protein levels in some cell, protein levels in some disease sample, and this was maybe error. So what can be the possible error in the protein level measurement? Are you guys able to understand? I just tried like giving you a biological example. Okay, so again, in this FMT, you can change it to different things. If I make it S, you have got a square shaped point, and if I make it this, you have got a line. This looks nice, right? It's like a line connecting all the measured points. And if you make it double dash, it just gives you a dashed line. And if you make it this one, what do you call this? It gives you a triangle. Are you guys able to understand? And that way, like you can change. And apart from this, I think I liked this one. Let's keep it. And okay, okay, we have the dots. There is one more parameter called as marker size. Marker size, it should be there. If it doesn't work, I'm doomed. Marker size 8. Did it work? Yeah, thank God. It just increased the size of the dots. Are you guys able to understand? This marker size is increasing the size of the dot. And then there is something called as marker face color. Hope it also exists. It will just change the color of the dot. Marker face color. What can be? Let's have yellow. Oh, it worked. Hope you guys are understanding. And then again, there is something called as marker edge width that you can try. I'll just write it in the comments. You can try marker edge width and you specify numbers like 1, 2, something like that. You can try that. It will control the border thickness. Now, if this was 4, this is called as vertical error plot because the error range is present vertically parallel to y-axis. What if you want to have this horizontally parallel to x-axis? So in that case, you just specify, make it x error, and if I change it, I'm just wait, copy everything, paste. Let's just change the name of the variables. I think that will be better. I'll make it x error. Hope it's not confusing. Is it confusing? Instead of writing x comma y, I'll write y comma x. We have got horizontal plot. Error in the horizontal direction. Are you guys able to understand? Okay. What if we have vertical and horizontal together? Right? So for that, add comma or we can copy paste, and after x is equal to x error, write y error is equal to y error. And this will use the one which we stored here. If you run this, hopefully there is no error. Okay, are you guys able to visualize this plot? Error on both x and y direction. Okay, like this does not make sense at this point. I'm just letting you guys know that you can have error in both x-axis direction as well as in the y-axis direction, and when you overlay both, it kind of looks like plus. And there is something called as e-line width, and if we set it to 10, you can see uh, the width of the error line is increased. Are you guys able to understand? I think it should not be 10. If it was 2, you have the thin line. If it is more than that, you have a thick line. Okay, so now what if it is unsymmetric error? Because whatever we have learned so far, it is all symmetric. So what if it is unsymmetric error? So in that case, let me just copy the error, x error, and copy it again. Let me just rename it. I'll just rename the first one as lower error and second one as upper error. And it is all symmetric now. Let me just change the upper error. I'll just make it 4 and 1, maybe 4, 4, 0, and this to 1, 0. Now it is unsymmetric. Do you guys agree? Now I'll create something called as asymmetric error, a variable, and equal to create a list, and within that list initially I'll specify lower error, comma, upper error. Any doubt till this step? Okay, hope there is no doubt. And I'll continue. Now, after that, let me just write plt dot error bar x comma y and comma y error is equal to, I'll specify asymmetric error now, and fmt is equal to O. Just run this because I want this xy values, because it gets updated, right? It gets overwritten. And if I run this now, this is an example for asymmetric error plot. Are you guys able to understand? Did you guys get the same plot? Hello? Did you guys get the same plot? You want the code? Okay, Ashnish got the same plot. What about Shalini and Ujjaswati? Okay, I'll just assume you guys got the same plot. Okay, now I think we have learned enough related to error bar plot. Let's go for violin plot. Do you guys remember violin plot from Seaborn? Okay, today we are going to try that in Matplotlib. But again, I repeat, in Matplotlib, violin plot is pretty complex. If you have a data set and you want to run a violin plot on a column, Seaborn is pretty straightforward. Violin plot in Matplotlib, it requires a lot more curation or modification in the data. So for violin plot, we can just write plt dot. Let's try importing something. Maybe df is equal to sns dot load dataset penguins. Okay, there is no error. And if I write plt dot violin plot, yeah, I think it needs some curation. We'll create a sample data. I think that will be easy. So again, we will use something called as np random seed random dot seed, and I'll write 42. Again, this is something like, we were using random state in machine learning. It is something similar to that. After that, I'll just write maybe a, and I'll write np dot random because I want to create something, and normal, and within the parenthesis I'll just specify size lock is equal to 5.0 and scale is equal to 0.5 and sorry 0.5 and size is equal to 100. And if I run this, there is no error. And if I print a, I have got a data set where there are 100 values. Now if you're wondering what is this LOC and what is this scale, uh, have you guys learned normal distribution? I think I did explain about normal distribution a little bit, right, during the ML sessions. Yeah. So in normal distribution, what happens is there are two important statistical parameters. One is mean, and the other one is standard deviation. So here, LOC is nothing but mean, and I'm writing mean is equal to 5, and standard deviation should be 0.5. And for this condition, I want a normalized set of values which should have 100 values within them. Are you guys able to understand? It's more like I'm setting the condition for the normal distribution, that is mean is equal to 5 and standard deviation is equal to 0.5, and I'm specifying that I want 100 values. You create that, like I want random 100 values and that should follow this condition. Are you guys able to understand? And can you guys confirm if you guys have got the same values as output? Because we have used random seed, right? Is 5.24 the same value you have got? Okay. So that's something like a magic. Even in neural network, you will use this a lot. np.random seed. And let me just create one more variable, b, and np.random dot normal. Now let's just change the condition. LOC is equal to maybe 0.6, if that, sorry, 6. And standard deviation, let's set it to 0.7. And how much value do we need? Oh, it should be same, 100. Because if we are going to form a data frame, the number of rows should be equal. And again, if you want to create one more, let me just copy paste this. And let me just change the value here. So 4, maybe 0.3, and again 100. Okay, so we have got 3, and or I think we can better name these things. Maybe like drug A and drug B and control. I think this will be like biological example. So now to create a data frame, df.data frame, sorry, pd.data frame, parenthesis, flower bracket. Now, what should be the column name? I'll just write control, the first column, and it should contain everything within the control. Yeah, so this is how I want it to be. And if I run this, okay, there is no error. Try printing the data frame. You should get this. Everyone got the data frame control drug A, drug B. Okay, okay. Now, let us create something called as data. And now I'll just create a list because for while in plot it requires list. And I'll just write df dot columns for column in df dot columns. There is no error. And if you print data, you will get this. Are you guys able to understand? So it's kind of like um how should I say? It's more like you're creating a list where the first one is control, comma, the second one is drug A and drug B. So there is no error. You write data and you get this. Okay, because while in plot it requires this how should I say, inputs and lists. Now we'll just create plt dot while in plt dot while in plot. and hope this will work. Wow, that was good. I feel happy now because this is something difficult even for me to do plotting in Matplotlib. Okay, we have got the violin plot. And can anyone tell me what are the two plots that the violin plot is a mixture of? I think I did mention this during the sessions. Can anyone tell me in the chat? There are two different plots. When you combine those two, it forms a violin plot. Even guess will work. Okay, I'll just tell you. Box plot plus probability distribution. Yeah, correct. KDE plus box plot. Correct, correct. So you have got box plot, which is represented by this line, blue line, horizontal and vertical, and you have got a lighter blue colored curve, which kind of looks like a violin. So it also tells you the distribution, and also, you know, it has given you the box plot also. So I don't think I need to explain the interpretation again, right? You're able to understand. The thing is, as we have three series, we have three different columns: control, drug A, and drug B. This first plot is the representation for control, and the second violin plot is representation for drug A, and the third one is for drug B. And the curve represents the density, probability density of the values, and this box plot, it also talks about the statistical distribution again. If anything is present beyond these horizontal lines or caps, that is the outlier. And here you can see there is something called as show means, and I have set it to true. That's why you have got a horizontal line in between, and that is representing the mean of the value. For example, for the first column, control, mean is around 4. Let's just check. So we can create, what was the function? I think np.mean. Yep, okay. So the mean of the control column is 4.01, and you have got a horizontal line at 4. Are you guys able to understand? Okay, cool. Now again, there are more parameters. This show means is one of the parameters. We'll try to look into as many parameters as possible, and then we'll just end the session. Now I'll just tell you there is something called as show median, which will give you again a horizontal line, but that line will be representing the median of the data for the column. So just write column within the parenthesis and write show medians. If you set this to true, you have got two lines, but you are not able to distinguish which one is mean and which one is median. Am I correct? Yeah, so your homework is to find out how can you differentiate mean and median by changing the color of those lines. You can set the color of mean line to red or something else, and you can change the color of the median line. And that is your homework. And there is again show extrema. Okay, if show extrema is equal to true, will there be any change in the plot? No. I think that will be set to true by default. If I make it false, you can see the vertical line has vanished. Am I correct? Yeah. So that show extrema will control, because when you have that vertical line, you will be able to understand what is the maximum value present in that column. I think the maximum value is near to 8 in the third column, drug B, and the minimum value is somewhere around 4.8, 4.9. So that is what it is trying to say. And again, you have something called as width. If I set width is equal to 0, it does not, sorry, width ts. Okay, this is how it looks like. If I set width is equal to 0.7, it kind of looks normal. If I set this to 2, it looks enlarged. Are you guys able to understand? Okay. 0.7, I think that is good. It looked better. Like if you feel like you don't know what to set for all these parameters, just don't mention those at all, so that whatever is default, that will be used, like to be on the safer side. Okay, so your homework is again, I'm repeating, how do you change the color? Yeah, I expect any one of you to send me a screenshot on WhatsApp with a photo where you have, changed the color of mean and median lines. Would that work? Okay. So you also have to send the code with the photo. And that is pretty much for violin plot. And I think you guys know you can, turn the violin plot upside down. You can make it horizontally. You can try playing with violin plots. I think that is basic in plotting. Like either you plot it vertically or you change the direction, you make it horizontal plot. Now the fourth one, sorry, the third plot that we're going to learn today. Oh, it's almost time. Let's finish this early. This is called as event plot. So event plot is a plot where you are basically trying to mark in a plot when did the event occur. For example, let's say you were working on a cell culture and you want to know when was the first cell division there. Let's say there was only one cell initially. When was the first cell division, and when did the second division occur in time, and when did the third cell division occur in time? So like you want to mark it on the plot. So something like that. It deals with events and time. For example, um, we'll do that. Before doing that, we'll just create a normal basic this event plot. So for trial is equal trial 1, let us have three different trials. Maybe call it clinical trials. And you have time values within the list. For example, the first like 1 comma maybe like 3 comma 4.5. So what I'm trying to say is under trial 1, three different events occurred, and the first event occurred at time is equal to 1, second at time is equal to 3, third event at time is equal to 4.5. Are you guys able to understand? Okay. Let me just create copy of this, and like we'll create three different trials and just manipulate the name. Make it 3. Here just change it. Maybe like 2 comma 2.5. Make sure you have only three values mentioned within the list. And in the third trial, let's make it 4, 4.5, 5.5. So we have three different trials. Now I'll create a variable called as trials, and within that I'll store all the three trials, trial 1 to trial 3. And now write plt.event plot and just write trials because the three will be inputted automatically. And then there is a line style that I'll explain you later. Just run. You get this. Are you guys able to understand? Now, one thing that might be confusing, we have only three different trials, trial 1, 2, 3, but on y-axis, let's say that x-axis is time. Let me just rename it. I think you will be able to better understand then. X label is equal to time, and y label should be trials. But you can see on the y-axis you have -1, 0.5, 0.5, something like that. But what if you want to change the x-axis, sorry, y-axis things? There is something called as y-ticks, and you can write 0, 1, 2 because there are totally three trials, or you can also make it 1, 2, 3. So this is how it looks. Are you guys able to understand? If I make it 0, 1, 2, if that is better for you to understand. Okay, maybe I think this is better. So, oh, okay, there is one problem. Three. I'll just make this 4.3. Okay, now look at the plot. Look at 0 on the y-axis. You can see, if you look at horizontally, on the 0 line, there are three different vertical blue lines. So that mark the timing of the events that occurred in the trial 0 or the first trial. Are you guys able to understand? The first event in the trial 1 occurred at time is equal to 1, and second at time is equal to 3, third at time is equal to 4.5. Are you guys able to understand how to interpret this? For trial is equal to, for the second trial, you can see the values are 2, 2.5 and 4.3. So you have the vertical lines at the same position. So the first line at x is equal to 2, and second it's at x is equal to 2.5, and third is equal to 4.2, 4.3, yeah. So this is how you interpret the y plot. If you don't want to have multiple things, what you can do is, let me just copy paste this, and let me write. We'll just take 5 more minutes. I'll just remove all these things. You can see there is only one event and you have got three different vertical lines. And if I even remove the grid, if you feel that grid is confusing you guys, you have got three different vertical lines. So the first event occurred at time is equal to 1, second at time is equal to 3, third at time is equal to 4.5. Are you guys able to understand now? I think it's simple compared to the previous plot. What about others? Ashnish and Urjoswati. Okay, okay. Now let's go for some modifications. Now, within this only, y text only, we can also create one more and we can write trial 1. So this is more like what happened was using y-text, I specified that I want only 3 points to be marked on the y-axis, and writing one more list after that, I just specified that I want these names to be present on the y-axis. There should not be 0, 1, 2. There should be like trial 1, trial 2, and trial 3. Are you guys able to understand? Just like renaming the points on the y-axis. That's what I did. Are you guys getting it? Okay, yeah. I think now this looks way more better. Trial 1, trial 2, trial 3. I think I can just remove the Y label as well. Right? I think this looks way more better for an event plot. So it is like marking you at what time the event occurred. And let me just teach you one more thing in data creation. If we want to create something for event plot. So what we can do is in NumPy, so if I create X and if I write 3 comma, oh sorry, 3 comma 2 comma 4 comma 6 comma 1. So this is clearly not in an order. It is not sorted. It is neither in ascending nor in descending order. So using np dot sort, and if I input X, I'll get an array where everything is sorted in the ascending order. Hope I'm making sense. Now what you can do is, as time should be always in the increasing order, you will never write time in some random order. For example, let's say cell division was happening and you want to create a synthetic data set, and I think you guys are aware that if I take E. coli as example, the cell division time is 20 minutes. So at like every 20 minutes the cell will divide. So the difference is going to stay uniform. There is not going to be any variation unless there is external influence. So you can write, um, for the time being I'll just create timings, and I'll write np dot sort, because I want things to be sorted. Within that I'll create random numbers. So I'll write np dot random dot uniform, because I want the difference to stay uniform, because as I said, in cell divisions usually the difference will be uniform. And you have to specify lower limit, upper limit, and the size. So if I write 0 is the lower limit or lowest possible value, and highest possible value is 12, and I want, let's say, 10 values to be generated. within this range, and difference should be uniform, and that should be sorted again. So if I write this and run, and if I print timings, I have got this. If I just make this 10, and this is 1, this is what you get. Are you guys able to understand what is happening here? You're getting an array that is in the increasing order. The difference is uniform, and to create this you are using this np.random function, which is used to generate random numbers, and this uniform over random will make sure that the difference is uniform, and then you are setting the limit for whatever you are creating. The minimum value should be 1, maximum that can be is 10, and total number of values that you want to generate, that is 10. And once the random numbers are generated, you want those to be sorted in the ascending order. That is what this np.sort doing. Everyone understood, right? It's like numpy within numpy. Okay. Okay, in this way, you can create like 3 different. So like you can create timings, maybe cells 2. There are 3 different cell types, let's assume, and there is cell 1, and here let me just write 20, and size let us keep it same. So I'm going to get cell division times for 2 different cell types for over 10 divisions. Am I making sense? Okay, I'll just create now something called as cells, and I'll just write cell 1 comma cell 2. I have created the list. Now it's time for me to call the event plot function. I want the time, I want 0 1. I will also add cell 1 comma cell 2. I don't want the grid, and this is what I get. Are you guys able to understand? Wait, I think there is something wrong with my explanation. You can see the difference between the 2 divisions is clearly not uniform. Am I correct? There is, I think, somewhere there is like very small difference, and then there is very large difference. Let me just try looking into this. Okay, guys, I just did googling. So what the thing is, this uniform function, it is not setting the difference between the two values to be uniform, but it said it is working on uniform distribution. For example, oh yeah, correct. Let us apply random state. Sorry, the random seed. Let's use the same np.random.seed is equal to 42, and let's rerun the code. Okay, is everyone getting the same kind of plot now? Okay, now, so guys, what happened was, I think if you guys remember my explanation, when we were generating data for violin plot, we used np.random.normal. And I told that whatever the set of values that we get, that is going to be normally distributed. So it will follow normal distribution. Now, here for np.uniform, np.random.uniform, what's happening is it is following uniform distribution. And uniform distribution is a kind of distribution where every point that is generated or present is going to have the same probability. Am I making sense? For example, if I print cells or cells 1, so you have, sorry, cell 1, right? Yeah. So you have 10 different values. Yeah, it's 10. So all the 10 values are going to have same probability. If there is 50% chance that the first value might occur, there is 50% chance that the second value might occur also. Am I making sense? And this is called as flat probability. I think this is something you will learn in statistics class. Sometimes what happens is you might have a data where you have multiple points 1 comma 2 comma 3 comma 4 comma 5. What if the probability of a point occurring is not same? For example, if I write probability and if I create a list again, what is the probability that 1 might occur? Let's call it 0.2. There is 20% chance. For 2, there is 30% chance. For 3, there is 40% chance. For 5, 50%. For 6, 60%. So here, probability for every point is different. Am I making sense? But in cells, what will happen is probability is going to stay the same. For example, if there is 70% probability that a point might occur, all the points in the data are going to have 70% probability. This is an example for like uniform distribution. Are you guys able to understand? And this is called as flat probability. And here, when you use this np.random.uniform, all the values are going to have equal probability, but the difference might vary. So it is not talking about the difference, it is talking about the probability. And this is how it looks. And again, you have something called as colors. Shall we continue the session for 3 more minutes? It's 10:42. Okay, so we'll just write colors and you can pass a list of 3 different colors. Let me have red. Sorry, I think there are 2 cell lines, right? So let us have red and let us have green. So you can see cell 1 is represented in red color, cell 2 events are represented in green color. So this is how you can change the color. And then there is one more parameter called as line length. So it talks about the vertical length of the line. So line length, if it is 0.2, you see you get a shorter line. Am I making sense? And then there is something called as line width, which talks about how spread out each line is. If I set it again to 3, you're going to get a thicker line. And again, there is one more parameter. I'll just give it as homework. Line offsets. Make sure you look into this. There is something called as line offsets. And again, within this, you pass a list. For example, you pass something like 1, comma 2, something like that. Look into what this does and what is its role and what change it does to the plot. So this is how the whole event plot works and event plot is all about. So it's about when you want to represent time of each event in a category. So this can be very helpful. I hope all of you understood. Okay. And also, if in future, if it comes in handy, if you guys use these things, whatever you have learned, please let me know. I would be very happy that at least like what I thought was useful. And that is all. I think it's 10:45, and I just wanted to know when are you guys leaving for VIT, because I can stop the boot camps around that date. Because I think you guys are consistent. I would just go with your timings. 7th. Okay, okay. Then I'm ending this on 5th. I don't think that should be a problem. Will not disturb you for 2 days. You guys can spend time with family. You guys can spend time in packing, etc. Yeah, I think that's all. I have recorded. Oh shit, all these things came in the recording. I'm going to cut it. Okay, guys, that's all. Thank you so much for attending. Good night.